mean? What does it mean to graph an equation, a quadratic equation of a parabola? So we're going to go and define exactly what a parabola is first, and then see what are the new terms that we're going to go and see for this particular section. And how do we use those two figures or those figures to help us graph our beautiful parabola. So here it is. This is what a parabola is. A parabola is basically defined as a set of all points. Again, they're going to be equidistant. Now, instead of being equidistant to one point, they're going to be equidistant to a point and a line. This point is called the focus, and the line has a specific definition. It's called a directrix, okay? Now, I give you guys a picture right here on the side of an example of the focus and a picture of the directrix. Don't think that the parabola is going to exist directly on the directrix or directly on the focus. It's going to be in the same distance away from each other. So let's go ahead and say that my focus is right here. My directrix is right here. It's equal distance away from each other. So wherever the middle of these two beautiful figures is, that's where it's going to be located. So here's one point. However, we have a set of points. So there's more points that are going to exist in between those two figures, okay? And there's specifics about it. That just doesn't exist with it. Go ahead. There's specifics about it. Now, my non-examples, obviously, we have a point and a line. Over here, my non-examples, I have what? Many points and what? Two lines. I don't want that as an example. I just want a point and a line. So the set of all points equidistant from a line called the directrix and a point called the focus. So I'm going to go ahead and label focus in red, directrix in blue, so we can go ahead and keep that uniform style throughout the lesson. Anybody need more time? Okay. It wasn't a vacation, guys. It was not a vacation. Not a vacation, huh? Her name is Alisa. Alisa Jovi. All right, listos. Ahora sí. Here we go. All right. So we have two types of parabolas. The first one that we're going to go ahead and call is the vertical parabola. So it's vertical, V-E-R-T-I-C-A-L, parabola. And it has these specific parts to it, guys. I want you guys to draw it. If you guys want to make or have your notes labeled on the left side, vertical parabola, the right side, we're going to go ahead and call it the horizontal parabola. So go ahead and divide it into two parts. Okay. So on my left side, or you can do top and bottom, however you guys want to separate it. Either left or right, up and down, top and bottom. So this is what a parabola that is open vertically or open towards the vertical axis looks like. Now, we have two axes, right? We have our x-axis. Let me go ahead and draw one right here, x-axis, and our y-axis. Our x-axis is opening, or it's basically the horizontal line. Our vertical line is opening vertically, basically up and down. So the reason why this one's called the vertical parabola is because it's opening, or it's basically directly opening towards the y-axis. So my y-axis is the line that goes up and down, right here. And I have my vertex is going to happen to be at 0, 0. So this is a special case that we're going to do today, guys. We're going to do vertex 0, 0. So that means that my beautiful x-axis has to go through here. This is my beautiful x-axis. Now, just so you guys know, all the points, they have a specific position. So here, notice that we have a distance. So for example, this distance from here to here is 1. This distance from here to here has to also be 1. So whatever it is on this side, let's say that this is D is 5. This one also has to be 5. Now, there's something else that has to happen. The distance from, let's say, in my y direction, from my x-axis all the way to the top, it has to be perpendicular to the other distance. So this one is the one that has to be right degrees or 90 degrees. And then it creates that beautiful point on the line sorry, not H and K, X and Y. So there can be many more. There can be this one. Let me go ahead and show you another one. Let me do it in, let's do it in graph. For example, this point right here, it has to be perpendicular. So let's say that this one measures 4. Therefore, the distance from here to here is also going to be 4. Another one. Let's say that this is perpendicular, measures 6. The distance from here to here is also going to be 6, and so on and so forth, right? So those are all the points that are graphed and create this beautiful parabolic figure that just goes the same distance away from the focus and the directrix. So remember that the vertex is that point that it's either the lowest point or the highest point, guys, of your beautiful parabola. And right now it's going to go through the origin, okay, 0, 0. This is a special case. So this is the origin. Beautiful. Okay, all right, everybody have this? All right. Now, like I said, the distance from here to here, from the focus to the vertex, from the vertex to the directrix, we're going to go ahead and label it as P. So make sure you guys label it. P. Whatever it is, it's going to be the same away from each other. So again, we're trying to find that midpoint between the directrix and the focus. Okay. All right. Now, this is the second case that we're going to have. The horizontal parabola. So parabola that's horizontal to itself or horizontally placed, it means that it's opening towards the horizontal axis. So this one's opening towards the y-axis. Sorry, not y-axis, x-axis. And it's going to open either left or right. So here's this one. Here's my beautiful vertex at 0, 0, which means that my other axis, my y-axis, happens to be the line that goes to that point like this. So here's the x-axis. Here's the y-axis. It happens to be horizontal because it opens up towards my x-axis. So very similar. Again, it has the same distance away from that beautiful point, creating all that parabolic figures, right? It creates that parabola. And the vertex is either going to be furthest to the left or furthest to the right. It's going to make much more sense right now once we start applying it. Take class. When it returns. Like that. That's why I have you guys do the left side, right side, or up and down. Or you guys have space to copy this down. Yeah. You got it? You got it? Okay. Anybody need more time? Yeah, am I going too fast, guys?
No, but I'm so sorry.
Okay.
Oh,
Let me know. Let me know. You guys can use that door too. Yeah, just as long as you guys don't cover the yeah. Okay, ahora sí, ¿listos? Anybody need more time? Okay. Let me go ahead and clear. Again, we have a beautiful directrix, guys, the line, and the focus. The focus is not the vertex. These two things are not the same. These two things are not the same. Directrix and a vertex is not the same. Vertex and a focus is not the same. They're all different from each other, okay? All right, so again, this is a special case for it being in the origin. So we have a case where the vertex is exactly at 0, 0. What happens? So again, there's gonna be a lot of information, guys, but we're gonna make much more sense right now that we go through it. So we're gonna go ahead and have a standard form of equation. If it opens vertically, how we're used to seeing it, either opening up or down, a quadratic equation, it's gonna have the equation of x squared equals 4py. Now, whenever we have that case, we like to isolate y. We're going to go ahead and isolate y. First, we divide by 4, then we divide by p. So therefore, we end up with 1 over 4p. X squared equals y. Instead of writing 1 over 4p, we're going to go ahead and create that as a beautiful coefficient and just call it a. So a squared equals y. Now, on the same idea, remember that we did inverse equations where we swap the x and the y. The same idea is going to happen here. So we're going to go ahead and swap the x and the y. And instead of opening up or down, it's going to open left and right. And our equation, we're going to have the x and the y swapped. So we have now y squared equals 4px. So again, we like to see our beautiful variable simplified or basically isolated. So we're going to go and divide by 4, divide by p. So therefore we have 1 over 4p. We're going to make that into a beautiful coefficient. I'll just label it a. So we have ay squared equals x. Now, how do we know that which one is which with a given information? If it's a vertical parabola, guys, we're going to go ahead and be given y equals a number for the directrix. So y equals a number. So y equals a number. In our focus, we're going to go ahead and be given 0 in our x direction. Our p, or basically our p, is going to be located in the y coordinate. So again, this is opening towards the y axis. Our horizontal parabola, it's going to be opening towards the x-axis. So again, we have x equals a number. We have a number in the x coordinate of our beautiful focus. It's gonna make much more sense right now. Ahora sí, ¿listos? We haven't even gone to the first example, guys. Yes. 5 minutes. Ándale. No, those are just the notes. Van a decir, ¿es una parabólica? It's the little dome looking like part of the dome. So if you were to grab that y lo cortas en muchos pedacitos, vas a agarrar como un platito. Y el platito es... No. Okay. Huh? My son went already on Friday, so I'm not taking. He already went, so. Okay, here we go. Listo. Anybody need more time? Se va la uno, se va las dos, se va las tres. Okay, here we go. Let me go ahead and clear this out. Here we go. Example number 1. Go ahead and copy this one down, guys. We have time. So this one is asking us to write and graph the equation of the parabola passing through the point of origin with the focus at 0, 2. Go ahead. And the directrix at y equals -2. So focus at 0, 2. Directrix at y equals -2. All right. So what is happening here? We're going to go ahead and first, let me graph what I have given. Focus 0, 2. Directrix at y equals -2. So my focus in this case is the point 0, 2. Let's go ahead and graph that point. What does it look like? Well, my x value is at 0. My y value is at 2. 0, positive 2 is right here. And I'm going to go ahead and label it as F so that I know that it's my focus. No, now I said that I have a line called a directrix. And in this case, it's the line y equals a number, -2. So it doesn't matter what my x value is, my y value is always going to be at -2. So is it going to be a vertical line or a horizontal line, guys? It's going to be a horizontal line. Horizontal line, however, it opens up towards what? My focus, the big F, that's right there. So this one is going to be a vertical parabola. As you guys see also that I have y equals a number. I made you guys do a little note. If I have y equals a number, it's vertical. If I have x equals a number, it's a horizontal. So in this case, I have a vertical. Now, what is the standard equation of a beautiful vertical parabola? X squared equals what? 4p and y. Now, my beautiful focus. My focus is said to be at 0 what? P. So what is my P value? 2. So I'm going to write P equals 2. So what do you think I'm going to do with this P value? I'm going to go ahead and substitute it. So let's go ahead and write my equation. X squared equals 4 times P times Y. My P in this case is beautiful 2. And let's go ahead and solve. So we have x squared equals 4 times 2 is 8 times y. We like to isolate our beautiful y. So all we have to do is divide by 8. So y equals, we can write it as x squared over 8. Or y equals, if we want the fraction outside, 1 over 8 x squared. Either way is correct. You can leave it, it's either or. Okay. Now, how do I finish my beautiful graph, guys? Where's the vertex in this case? It's at the what? El origen, what's the origin? 0, 0. So it happens to be here. Now, remember that we said P has to be the same value from the focus to the vertex and vertex to the directrix. So is it 2 units? 1, 2. Yes, it is. 2 units, 1 and 2. So therefore, it's always opening towards the focus. So all we have to go is up and up. Now, how specific do we have to be with the rest of the points? It does not really matter. We don't want to focus too much on those points. All we want to focus is on or at the parabola, and then where the focus is located, directrix, and then the equation. Okay. How do you feel about these? Okay. Yeah, you're doing the next one. I'm not kidding. Everybody has this? Okay, perfect. Woo! Go ahead and try example number 2 on your own. Let's see what you guys get. Focus at 0, -5, directrix at y equals 5. With your beautiful neighbor or yourself. I have y equals a number. So which one tells me that I have y equals a number? Vertical or horizontal? Yeah, it's y equals 5, but y equals 5 a number? So look back at your notes right here where I told you guys this part. So my directrix says y equals a number, x equals a number. So which one is it? It's going to be vertical. So I'm going to have it either opening up or down. Woo, okay. All right. So let's go back to my example. Here it is. Let me go ahead and graph the focus. My focus is at the beautiful points, 0, -5, 0, and -5 is down here. My directrix is at y equals 5. So any value that I have for my y, no matter what x is, y is always going to be +5. Let me go ahead and redo that because it's a little bit slanted. It's not perfectly fine. There you go. Okay. Now, remember that in this case, or the cases that we're doing today, are for my vertex being at the origin. We haven't transformed them. We haven't shifted them anywhere. It happens to be at the origin. So where do you guys think this is going to be opening towards? Up or down?
Up.
No.
It's going to be down. It's always towards the focus. Away from the directrix. Okay, so here's my focus. Here's my beautiful vertex. And again, this is my beautiful directrix. Okay. All right, now let's go ahead and write the equation. Which equation am I using? Markia, which one am I using? Which standard equation? If I'm using the vertical. X squared equals, there you go, 4py. Guys, I need it quiet. So my focus is at 0p. So what's the value of p? -5. So p equals -5. I'm going to go ahead and substitute that value right here. So let's go ahead and write that out. I have x squared equals 4 times -5. Why? Let's go ahead and simplify. X squared equals 20. However, it's -5, so it's -20. Why? And then divide by -20, divide by -20. There's two ways to write this. Either y equals x squared divided by -20, or y squared, take out the fraction, 1/20 negative x squared. Remember that my coefficient is going to be outside or in front of my beautiful x squared. So either way is correct. I like to use the other one since I have my coefficient now. Okay. How do you feel about these? Okay. The other example, guys, or the other case where we have x, the other directrix. Everybody has that? Yes, let me go ahead and clear. We have it facing either left or right. My directrix in this case is at x equals +4. So here's my directrix, +4. In this case, it's going to be a vertical line. And here is my beautiful focus at -4, 0. Again, my vertex is at 0, 0. This one is going to open towards the beautiful left. Okay. In this case, instead of using x squared, we're going to use what? Y squared equals 4py, sorry, 4px. Ooh, Dios mío. Where my focus, again, it's going to be at p and 0. And the value of p is going to be substituted in here again, okay? So we're going to go ahead and proceed with the same procedures or with the same idea. So we have y squared equals 4 times -4. X, y squared equals -16x. All we have to do is isolate x. So we divide by -16. So x equals -1/16. Yeah, -1/16 y squared, this case. Woo! Okay, there you go. Okay, let me go and give you guys your homework. We'll see.
Tomorrow will be good.